So today we're going to walk through an equilibrium constant question. It says that hydrogen gas can be made by reacting ethanol with steam in the presence of a catalyst. And it wants us to give us the expression for Kc for this equilibrium, and it wants us to state its units. So the expression for Kc is quite simple. Just carbon monoxide squared, because there's a 2 in front of the carbon monoxide, multiplied by, you don't need the multiplication sign, I'm just writing it anyway, over the reactants, steam, water, and ethanol, C2H5OH. Now when it comes to working out the units of Kc, remember that all of these are concentrations, so it's going to be moles per decimeters cubed to the power of 6, because 2 plus 4 is 6, divided by moles per decimeters cubed squared. Let's just move to the side. That's going to be moles to the power of 6 decimeters cubed to the power of negative 18, and moles squared over decimeters cubed to the minus 6. And then you just apply your index laws. So that's going to be moles to the power of 4, and our decimeters cubed minus 18 minus 6 minus 12. Okay, so that was quite straightforward. Let's look at the second part of this question. It says that table 4 shows the amount of each substance in an equilibrium mixture in a container of volume 750 centimeters cubed, and it wants us to calculate Kc. So all we have to do is you have to find the concentrations of each of our different substances and put them in the equation. Remember that volume is in decimeters cubed, so that's going to be 0.75 decimeters cubed. So we just substitute all of these values into our expression for Kc, so I'll just skip ahead to that. So this is what we get when we substitute everything into the equation, and our answer to this should be 7.66 times 10 to the minus 3. So the last part of the question asks us to predict the effect of increasing the pressure on the equilibrium yield of hydrogen. And then it wants us to find the effect of the increase of the pressure on the value of Kc. So firstly, when we consider the effect on the equilibrium yield of hydrogen, we know that when we increase the pressure, the equilibrium will shift to the side with the fewer moles of gas. Okay, so on the left hand side we have 2 moles of gas, and on the right hand side we have 6 moles of gas. So that means the equilibrium will shift and favour the backwards reaction. So that means we'll have a reduced yield of hydrogen, and our explanation for this is that our equilibrium, I'm just going to write EQM for that, will shift to the left, and that's because there are fewer moles of gas on the left hand side, and then the equilibrium basically just shifts to oppose the change of the increased pressure. Now when we consider the effect this value has on Kc, know that the only thing that affects Kc is temperature. So if we change the temperature, that will affect the Kc, but a change in pressure will have no effect on Kc. So that was just a quick walkthrough today. Hope you guys found it useful.